Welcome back. We are back in this SVT, hopefully gonna have this thing all wrapped up tonight. You may notice, if you are a keen observer, these capacitors are different than the ones from the last video. Turns out so this cap, which was the original one that we need to replace, as well as these guys, the replacements I ordered, I checked the footprint, I checked the width for the pins, I checked the width of the cap itself to make sure there was enough clearance. I did not check the height. I assumed since these guys were as tall as they were, everything would be okay. However, inside this chassis, there are height restrictions. So that started with this cap being too tall, so I ordered it, replaced it, got a new one in there, and then only to find out that these guys were also too tall from my initial parts order. Let's see if I've got, so not much of a difference, but definitely in the scheme of things on a PCB, a lot different. So let my mistake be a good lesson to anyone out there doing a cap job on one of these SVTs. Make sure you measure the heights of all the components that you're replacing, because otherwise it will not fit when you go to put that circuit board back in. Now, we also have replaced these heater connections. I can't remember if we did that on the last video or not, but definitely done now. Have some nice, these are the heater wires going to the power tubes from this transformer here. These guys had been all burned up, so we have some nice new right angle plugs there, which again we had to get because the ones that are just a vertical kind of crimp-on connector were too tall for the circuit board. So we're going to put this thing all back together. I'm going to power it up, make sure everything is okay, make sure there's nothing wrong. I've triple checked the polarity on all these capacitors to make sure we're not going to have an issue there. Made sure that the voltage and the capacitance is correct. We could always exceed the capacitance, we could always exceed the voltage. However, we want the capacitance to be the same for all of these. To be honest, there was only like one or maybe two options for each of these capacitors on DigiKey or Mouser at the time that I ordered. So I just bought the exact same part because that's what was available. And let's get this circuit board back in here. I'll probably keep it out of the chassis for the initial power up. And hopefully there's no other issues. Going to power up without tubes. Measure to make sure that I have voltages that are reasonable, within expectation. And then if that looks good, we will hook it up with tubes, see if things bias up correctly. And if that looks good, we will then put it back in the enclosure, do a sound test, make sure that we don't go into our cutout condition. Okay, let's get this thing back together. All right, so our board's back in. We are powered up. You can see I have this guy resting on the transformer there as a way to then check some voltages. Got 699 volts DC on the plates, which is, again, another reason why people don't like working on these. I've got my ground probe connected, or my black probe connected for volts DC to the ground lug. You can see here we are in green mode because there's no tubes connected, so there's no problem with the bias. Now, I'm not going to show actually taking these voltage checks, but what I've done is measured the voltage for the plate, the screen, and the bias for each of the tubes, being very careful, and confirm they are all good. So our next step is going to be to power this thing up with the tubes in. See if everything's good, see if we can get some sound out. I'm going to do a very minimal sound test at a low volume. check the bias, let it heat up for a little bit. And then if everything's good, we will then power it back up in the enclosure and do a sound test, let it sit for a long time. See if we can get anything to fault out. Okay, here we go. Okay, so we are unplugged from the wall. Our plate voltage is dissipating slowly, but there is something else to consider here. So all of these points are the spots where we just changed those capacitors. So there's close to 40 volts sitting there, 33. That point has 30. So if we were to reach around underneath this chassis and accidentally touch one of these points, we easily could zap ourselves. 10 volts there. Okay, so here's what we're going to do. We are going to switch over. We have our black lead connected to it's hard to see underneath there. I'll show you after we do this procedure. But we're going to switch over to our current mode, which is fused. Switch to DC current. And then I'm going to, well, let's see, we could do this a couple ways. I could touch one of those points where the new capacitor positive is, or I can go back to the plate resistor and you can see our milliamperage dissipating. You don't want to do this with the full 700 volts. You'll get a little arc. But if it's at a couple hundred volts even, you should be safe doing this if you know what you're doing. But again, be careful. Also be careful taking these voltages. If I were to do these same checks down here, you could short and touch your probe to this grounded tube retainer socket and have a direct short to ground from your plate voltage, which will blow your fuse. And it's a 10 amp fuse in these guys. Okay, let's switch back over to volts. And again, measuring volts DC. All right, now we're at 0.3 volts. And if we check around all these points where we were changing out caps before, if we don't see anything over like a couple volts, ideally less than a volt, we should be good. Okay, and we're unplugged. So let's get some tubes in this and see what happens. Okay, so we are powered on. Tubes are in. I put them back in the arrangement they were in before for the 6550s to make sure that the pairs are correct for the bias. We have two 12AU7s and a 12AX7. That's very important. If one of these is accidentally a 12AX7, you won't be able to bias this amp up correctly. And now we're going to let this thing sit and warm up. You can see we basically just want green lights there. And there are instructions that say you just want the green light. So you can adjust this. See if I go too far clockwise, the red comes on, but we just want the green. Now if you go too far, the green will turn off. You want to be right about there. And you're not going to hurt anything by going too far. It'll go into protection mode if you are about to. But really, these amps limit things before you get to that point. But assuming this warms up for 20 minutes or so, everything stays good here, we should be good to do a little sound test. And we'll see if it goes back into, if that light on the front turns red, we are in protection mode. So I'm going to let this sit, and I'll check back in with you guys. But the goal here is to just adjust these as needed, and to not touch anything in here that will hurt you a lot at best and kill you at worst. Okay, we'll see what happens here. Okay, it's been about 20 minutes. You can see we are still looking good. And I don't currently have this hooked up to a 300 watt speaker, but I did plug a guitar in and do just a very low volume test to make sure we were getting sound and a nice clean sound. But once again, I just want to show you how small of a movement goes from no light. Look how much I'm twisting this. Green light to red light. That's hardly anything. So that's good. That's bad. Good. Bad. So when we're setting our bias, we want to start from nothing and then come up to the green. You can even see where the red is and then back it back off. And again, we'll do it for this one. These are operating independently. So that should be good. And you do this when it's idle, not when it's playing. When it's playing, those red lights will come on because you're changing the signals going through the tubes. Okay, so at this point, we are going to turn the amp off. We're going to discharge. We're going to make sure everything's nice and tightened down. And then we are going to get it back in the enclosure. And then I'm going to put it on a proper 2x15 cab, run some signal through it for a while, make sure we don't go into protection mode. I don't see any reason why we would at this point, but that was the initial reason this amp came in. And then we found the bulging filter capacitor, which needed to be changed out. Okay, so I'm going to go ahead and do that, and then we'll report back if there's anything to report.